I'm Mark Yarlott, and I want to introduce a video that I've done with Terry Nelson. Anyway, this month I wanted to have an interview with him on asset hierarchy. He's been very instrumental in developing the hierarchy strategy that Veolia Water uses, and he's been working on this for a really long time. Just before we did the interview, I was looking through some old files and found a file that he gave me a couple years ago that's got dates from 1993. So take a look at this. If you've got questions or comments, if you're watching this on YouTube, just give comments or write down below here. You can enter those in. We'd love to hear from you and get some feedback. We definitely want to make this a conversation. So thanks for watching, and see you next month.
Just to understand hierarchy, probably one of the things that's most familiar to us in this day and age is Windows Explorer.
Right.
When you go into your My Computer Windows Explorer, you've got your folder that's your computer. That's just one thing. You open that up, and you'll have, your different drives or whatever. So you've got a very short list of things under your computer that you can pick from, 4 or 5, whatever. So you pick the one that you want, you open that up. That gives you another short list of which one am I in. So we use that same kind of structure in wastewater, water, whatever, when we have these thousands of assets. So we can go in and say, well, let's say we have multiple plants, and we know that we've got this concern, right? So we're going to go enter something in our CMMS, and we want to go to the right place, and we want to put the data in. So what we'll do is we'll go in there, we'll have this thing in mind. I've got the return activated sludge pump is making noise, right? When I go in there and I look at this thing, I know which plant I'm in. That's all I have to pick. Which one of my 4 or 5 plants am I in? You pick your plant.
Right.
That gives you the processes in that plant. And you see, okay, I've got primary treatment, secondary treatment, whatever, your 4 or 5 processes. You go, oh, well, the pump will be in this. So you pick one process. That gives you 4 or 5 systems, right? Oh, it's pumping, not aeration, so you pick the pumping system. Now you get just a handful of assets, a screen, less than a full screen full, if you will, not even scrolling, of here's all of your, commonly, I might be generalizing there, but some large complex systems could have to scroll, but you get a finite list of closely related assets, all the things that are in that RAS system.
Right.
Now, at this point and with this value, you may have been thinking a particular pump, but you may look at and see what that list is and realize, you know what, maybe this problem isn't that one pump. Maybe it's having to do with these 2 or 3 pumps, or maybe it's the pump and its controls. So the system can present you with your best choices, and then you can make those best choices. It works very well for us as humans because we can only keep so many things in our mind floating around at once as far as a list.
Right.
So the shorter lists we can give ourselves to pick from, the easier it is for us to make a good choice amongst that list. And then getting information back out is a really important thing about what kind of hierarchy you use. The 3 basic types are functional, locational, and what I call a financial responsibility. An organizational scheme, a tiered or hierarchical organization scheme, hence the word hierarchy, that organizes things into this pyramid structure. And it's very common to use location. It's very common when people go to do a CMS to say where something is really important and most intuitive to the users. And to some extent that's true, but it always breaks down because when you go for 100% coverage, meaning all of your physical assets, everything that requires maintenance resources, then you have it fall between locations, whether you're in a wastewater plant, a collection system, a water distribution system, or any kind of other large network type organization. There's things between the things. So the locational thing breaks down. The other issue with locational is that really as we get into asset management and we start managing our systems, we've got a lot of functions that are related to groups of assets. So we really move away from individual asset thinking and towards groups of assets thinking. Probably the best example is a simple pumping station with a lead and standby pump. When we start out in maintenance, we're concerned about making both pumps do their jobs as pumps. As we learn and get more into what those pumps are doing, we discover that those two pumps have different jobs. One has a pumping job, and one has a ready-to-take-over pumping job. And those have some different things, different drivers that might change maintenance on them. But the biggest picture there is now, as these two pumps are diverging in roles, we also start seeing that the roles of the pumps aren't as important as the role of the pumping system. So when we go to talk about criticality, when we start talking about what happens if something fails, we have to look at it as the group of assets. One of a good clarification on that, and it also goes towards the 100% coverage, is we think a lot about what happens if pump 1 fails, pump 2 will take over, what happens if pump 2's not ready, pump 1 better not fail. So we look really hard at the pumps. But how often do we look at what happens if the suction cross-connect T breaks?
Right.
We could easily have an erosion in this pipe elbow, and it takes our whole system out, and we haven't even really looked at anything except the pumps. So we have a valve problem, a piping problem, a control problem, then it does worse than the overanalyzed pumps, which after all, we have 2 of them in the first place. So probably when we go analyze what could happen to our system and the functions that we need to deliver from that system, then we have already put our focus on the wrong place, because somebody's already dealt with the problem. What if the pump quits?
Right, and that's one of the things that I've noticed, that, coming from the engineering design side of things, is the engineers sort of think of things as, they put 2 pumps in there because they want the redundancy, because they want the system to perform a certain function. And so it kind of goes hand in hand with the engineering design side of things too. So it's kind of cool that way.
Absolutely. And the thing is that you've got to remember, you've got to keep your focus on the system, not on the pump, not on the individual asset. Asset management, oddly and perhaps ironically, is not really asset management. It's system and function management, as we know. So that's where we've got to align our CMMS, which is not asset management. It's simply the key central tool to, or traffic cop sort of, to manage parts of the system that are asset management. But we have to use other things in addition to CMMS. The CMMS is just sort of the first place we look and the first control we look to, and normally the first thing we establish. And that's not a bad thing, that's a good thing. So what that tells us is, now to achieve the 3 important things in a CMMS, we have to have some kind of organizational structure, and a tiered structure makes sense because it allows us, again, to make a few selections from short lists as opposed to one selection from a huge list, just having a bulk of assets. We see that's important. Now when we start talking about overall the other asset management aspects, then we have to, that's when we look at and say, well, do we want to do locational, functional, or responsibility? The financial responsibility, just to hit that for a minute, is a lot of times people will organize, and we see it a lot in paper mills and especially oil refineries, where the oil refinery is a set of processes that are assigned to these groups of responsibility, and then those sets of processes or areas of the plant or whatever they are, that they are kind of handled independently, sort of like modules. So you'll go into a lot of oil refinery CMMSs, and you'll see the hierarchy is basically whose fault is it if this breaks then? And that's how it's organized. So you have this functional disconnect over, hey, if this process over here stops feeding this process over here, then that's a problem. You lose that because, you know, Joe, who's in charge of this thing over here, is counting on Bob, who's in charge of this thing over here, to feed him what he needs and take what he doesn't need. And so you just kind of totally disconnected that. So we see a loss of really asset management if we use anything other than a functionally organized hierarchy.